Good morning, everyone. Myself Sachin Prakash. I am a senior faculty of chemistry in Narayana IT Academy, and today we are going to discuss about the paper which was conducted for JEE Mains 2025, 22nd January Shift 1. Okay, so the chemistry paper is of a moderate level with some questions being a bit calculative. The rest of the paper is pretty much normal for students to navigate through. Okay, so let us start with the paper discussion and we'll move to the first question, which is question number 51. In question number 51, the question is which of the following electronegativity order is incorrect? Now, the answer will be option 3 because from left to right, okay, the electronegativity order increases. So, magnesium should be having lesser electronegativity than aluminum, which makes the option 3 incorrect. Okay, rest of the trends are correct. Next, question number 52. Radius of the first excited state of helium ion is given as A naught. Given as A naught is referring to the radius of first stationary state of hydrogen atom. Now, radius of nth orbit is given by A naught n square by z. Okay, for helium, this value will be equal to 2, which is the atomic number. Okay, and first excited state means that n is value is 2. So it will be equal to A naught into 2 square by 2, and this will be equal to 2 A naught. So the answer will be option 1. Okay, so this is a question of atomic structure and pretty much formula based. Okay, so after that we have got question number 53. Which of the following complexes CFSE means crystal field stabilization energy delta naught will be equal to 0? Okay, so in this question, okay, the answer will be K3 FeCN6 because in this case you have got a D5 configuration for Fe3 plus and you have got a strong weak field ligand SCN minus. So when you are writing the EG and T2G levels, okay, then this is the T2G and this is the EG level. So the D5 configuration will come out to be 1, 2, 3, 4 and 5 because with weak field ligand the electrons will be promoted from T2G to EG after the third electron. So if I am calculating the CFSE value, then it will be equal to number of electrons in the T2G orbitals. Now T2G orbitals have minus of 0.4 delta naught energy per electron, while EG value electrons will have plus of 0.6 delta naught per electron. So it will be number of EG electrons, which is 2 into 0.6 delta naught minus number of T2G electrons, which is 3 into minus of 0.4 delta naught. This value will come out to be 0. Okay, if you do calculations in other cases like K4FeCN6, okay, the values will not come out to be equal. In case of K4FeCN6, okay, it has got Fe2 plus ion, which is a D6 configuration, and with strong field ligand, which is Cn minus. Okay, it will have T2G6. Okay, which will not be equal to 0. It will be something like minus 1.2 delta naught. Similar things will be there in case of option 3 and option 4. So only option 1, the CFSE will come out to be 0. Okay, next moving to question number 54. A liquid when kept inside a thermally insulated closed vessel at 25 degrees centigrade was mechanically stirred from outside. What will be the correct options for the following thermodynamic parameters? Okay, so when thermally insulated vessel is there, this means that Q value is equal to 0. And from the first law of thermodynamics, we can say that delta U will be equal to Q plus W and Q will be equal to 0. So This gives us that for this system, delta U will be equal to W. Now W here is positive. Why? Because we are we are doing work on the system. Okay, so W will be positive, and if W is positive, then delta U will also be positive. So the option will be that delta U should be greater than 0, Q should be equal to 0, and W should be greater than 0. So that will mean that the option 2 will be the correct option. Next, question number 55. So this brings us to question number 55. They are asking the incorrect statements regarding geometrical isomerism. Option A, propene shows geometrical isomerism. Now propene structure is something like this. So one of the sp2 atoms are connected to two hydrogen atoms, and if identical groups are connected to sp2 carbon of a double bond, then it will not show geometrical isomerism. So option A is incorrect. This brings to option B. Trans isomer has identical groups on both sides of the on the opposite sides of the double bond. So this is a trans isomer. Let us say we take trans 2-butene. So you see this CH3 groups are on the opposite sides of the double bond. So B option is actually a correct statement. Cis butene will have higher dipole moment than trans butene. Now this is trans butene. Cis butene will be something like this. Now in this case, the dipole moment vectors will be like this, and they will be cancelling out each other. So in case of trans isomer, mu will be equal to 0, while in case of cis isomer, the dipole moment vectors will be aligned along these directions. Okay, so in this case, mu will be greater than 0. Okay, so cis will have cis isomer will have higher dipole moment than trans isomer in case of butene. So this is a correct statement. Now, 2-methyl butene shows two geometrical isomers. Now, if we draw 2-methyl butene, it will look something like this. Again, in this case, there are two CH3 groups which are connected to sp2, same sp2 carbon. So this double bond will not show geometrical isomerism. Okay, so this is an incorrect statement. Option E, trans isomer has lower melting point than cis isomer. Now, trans isomer is more symmetrical. So the packing of the molecules will be more efficient in case of trans isomers. So melting point should be actually higher in case of trans isomer compared to the cis isomer. So in case of trans isomer, like this one, there will be something called a center of symmetry, which makes the molecule highly symmetrical and hence increases the melting point. So trans isomer should have higher melting point than the cis isomer. So option E is also incorrect. So A, D, and E are incorrect. So the correct answer is option 4. This brings to question number 56. Arrange the solutions in the order of increasing boiling points. Okay, so boiling point TB will be increasing as delta TB increases. And delta TB is proportional to molality. And molality will be proportional to molarity. Okay, so if molarity increases, then molality will also increase, delta TB will also increase, and TB will also increase. In this case, if we take 10 to the power minus 4 molar NaCl, then effective molarity will be I into 10 to the power minus 4, and here the value of I will be equal to 2. So it will be 2 into 10 to the power minus 4 molar. The more is the number of particles, higher will be the colligative properties. So in second case, when you are having 10 to the power minus 4 molar urea, then the effect is I value is 1 only. So M effective will be equal to 10 to the power minus 4 only. In case of option 3, you got 10 to the power minus 3 molar NaCl. Again for this, M effective will be 2 into 10 to the power minus 3 because I value is equal to 2. In this case, I value is equal to 1. In last case, which is 10 to the power minus 2 molar NaCl, again I value is equal to 2. So effective molarity will be 2 into 10 to the power minus 2. So in fourth option, the concentration is highest. Okay. So the delta TB will be highest and hence the boiling point will be highest. So the order should be same as the order of decreasing M effective. So it should be 4 greater than 3 greater than 1 greater than 2. So the correct answer as per the given options will be option 1. Question number 57. Given below are two statements. Statement 1, 1 mole of propine reacts with excess of sodium to release or liberate half a mole of hydrogen gas. Okay, so propine is something like CH3, 1 minute, CH3, C triple bond CH. So when it reacts with sodium, sodium will give electrons and electrons will, you know, get absorbed by the acidic hydrogen because there is a delta plus and delta minus here. And you'll be getting CH3 C triple bond C minus plus H dot, which will combine with another H dot to give H2 gas. Okay, so if you take 2 moles of propane, then you'll be having 2 moles of Na, then you'll have 2 moles of this, 2 H dot, and okay, this is not working. 57, we have to repeat. Okay. Question number 57. 1 mole of propane reacts with excess of sodium to liberate half a mole of hydrogen gas. Now the equation is like CH3 C triple bond CH plus Na. The reaction will give CH3 C triple bond C minus Na plus half a mole of H2 gas. So this is a correct statement. Statement 1 is correct. Now statement 2, 4 grams of propine reacts with NaNH2 to liberate NH3, which occupies 22.4 ml at STP. Now propine, the second equation will be CH3 C triple bond CH plus NaNH2. This will give CH3 C triple bond C minus Na plus NH3 gas, and this NH3 gas will be liberated. Now if you see the molar mass of propine, it will be like this part is 15, this part is 24, and this is 1. So total molar mass is 40. Now so if you are taking 4 grams, this will be 0.1 mole of propane. So 1 mole is giving 1 mole, so 0.1 mole will give 0.1 mole of NH3. Okay, this if at we want to calculate at STP, it will be into 22.4 liters, and this will be like 2.24 liters. Well, the given is option is 224 ml. So this is at STP, which is not correct. So statement 2 is incorrect. So the option should be that statement 1 is correct, but statement 2 is incorrect. So the correct option will be option A or option 1. Okay, after this we have got question number 58. A solution of aluminum chloride is electrolyzed for 30 minutes using current of 2 amperes. The amount of aluminum deposited at cathode. So you see, first we need to calculate the charge. Q will be equal to I into T. That will be equal to 2 into 30, and this should be in time should be in seconds, so into 60. and we need to calculate to convert it into Faradays. So divide 96,500. This will be the number of Faradays of charge. So if you so 6 3 ja 18 2 ja 36 by 96 965 Faradays. Now the equation is Al3 plus 3 electrons giving aluminium. So 3 moles of electrons will give 1 mole of aluminium, which is equivalent to 27 grams of aluminium. Now 3 moles of electron will be equal to 3 Faradays. So for 36 by 965 Faraday, the amount of aluminium deposited will be 27 by 3 into 36 by 965. So this will go like 12 times 12 7 is 84, 4 8 12 2 is 24, 8 32, 324 by 965. Okay, if you do the calculations, it will come out to be 0.336 grams. So the correct answer is option 4. Okay, so after question number 58, next is question number 59. Now in 59, the from the magnetic behavior of NiCl4 2- paramagnetic and NiCO whole 4 diamagnetic, choose the correct geometry and oxidation state. Now for NiCl4 2-, chlorine will be like -1. So, so nickel should be in 2+ oxidation state. Okay, and this should be a D8 configuration. Okay, now this is a tetrahedral complex because Cl minus is a what you call as weak field ligand. So with coordination number 4, you will get a tetrahedral complex. With NiCO whole 4. Now carbonyl group is having 0 charge, so nickel will also have 0 charge. So you have basically got nickel neutral, which is 4s2 3d8. But CO is a strong field ligand. Carbon monoxide is a strong field ligand. So forced pairing will take place. This will become 3d10. If that is happening, the coordination number 4 again has to be satisfied by sp3 hybridization because there are no inner d orbitals which are vacant for giving a dsp2 type of hybridization. So in this case also it will be a tetrahedral hybridization only. Okay, so the correct option should be NiCl4 2- tetrahedral and NiCO whole 4 also tetrahedral. So 59 option should be option 4. Okay, next is question number 60. Now this is an easy one. Which of the following acids is an vitamin? So it should be ascorbic acid, which is basically vitamin C. Okay. And aspartic acid is an amino acid. Adipic acid is a dicarboxylic acid. Okay. Saccharic acid will be getting from glucose. So only ascorbic acid is vitamin, which is vitamin C. Next is question number 61. Now, in question number 61, the products formed in the following reaction sequence are. Okay, so first step is reaction with bromine acetic acid. So let us start with the given reactant, which is this, with bromine acetic acid. Okay, now this is already a deactivated ring, so only monobromination will take place, and that too at meta position with respect to the electron withdrawing group. because NO2 is a meta directing group. Then with SnSCl, which is metal acid reduction, NO2 will be converted into NH2. Then there is a classical case of NaNO2 plus HCl, which combination gives HNO2, and HNO2 combines with NH2 to give N2 plus. Sorry, this is bromine. And this will undergo reaction with C2H5OH. Now C2H5OH in this case will be acting as a reducing agent, and in that case it will get converted into CH3CHO, and the H minus ion, which is the least, will reduce N2 to plus to hydrogen. So the final product will correspond to something like this. So you'll get bromobenzene, and C2H5OH will become CH3CHO. Okay, so the correct answer should be option 3. Okay, which of the following statement is not true about radioactive decay? Okay, so option 1, decay constant increases with increase in temperature. Now radioactive decay depends on the nature of the nucleus. Okay, so decay constant will be constant with temperature. Temperature is not going to affect the decay constant lambda. So option 1 is incorrect. And then it's a single correct question. So this will be our answer also. So 62 answer should be 1. But let us look into the other options. Half-life is Ln 2 times 1 by rate constant. So T half is Ln 2 by into 1 by K. This is a correct statement. Decay constant does not depend on temperature is correct. That's why we have, so third option is also correct, and amount of radioactive substance remained after 3 half-lives will be 1 by 8. So n will be equal to n naught by 2 to the power n, where n is the number of half-lives. So it will be n naught by 2 to the power 3, which is 8. So this is also a correct statement. So the only incorrect statement is option 1. So 62, it should be 1. Okay, next we have got question number 63. Question number 63 says, which of the following electrolyte can be obtained by H2S2O8 by the process of electrolysis? The correct answer should be option 1, which is concentrated sulfuric acid. See, when you have got concentrated sulfuric acid, okay, then H2SO4 will be giving H plus plus HSO4 minus. Okay, and what will happen is that at anode during electrolysis, 2HSO4 minus will be losing 2 electrons to give H2 S2O8 plus 2 electrons. Okay, so at anode oxidation will take place. Obviously at cathode reduction will take place. The H plus will react with electron to give 2H plus 2 electrons with hydrogen. So this happens with concentrated H2SO4. Okay, with dilute H2SO4, the reaction is similar to reaction products are similar to that of electrolysis of water. So 63 answer is option 1. Question number 64. Now statement 1 is CH3O CH2Cl will undergo SN1 reaction through its though it's a primary halide. Now that will be a correct statement, because if we make the carbocation by removing chloride ion, which is something like this carbocation will get back bonding stability. So it will be a highly stable carbocation, and though it's a primary halide, a stable carbocation will always undergo SN1 reaction under appropriate conditions. So statement 1 is a correct statement. Okay, statement 2. This is new pentyl chloride. So it is something like this. Now, this is the alpha carbon which contains a bulky group. So backside attack through SN2 will be very difficult. So although it's a primary halide, due to bulky group at alpha carbon, the backside attack through SN2 mechanism will be sterically hindered. So in this case, the given reactant will not undergo SN2 reaction easily. Statement 2 is also correct. So we should look for the option where both statements are correct, which brings us to option 3. So the 64 answer should be option 3. So next is question number 65. The question says that the compounds which will give positive Felling's test. Now for Felling's test, okay, the compound should contain either a aldehyde group, okay, or a alpha hydroxy ketone group. Okay, if a compound contains these two groups, then it will give the Felling's test. But aromatic aldehydes will not give Felling's test. Okay, so option A will not give Felling's test. Option B is just a ketone, so it will not give Felling's test. Option C is an alpha hydroxy ketone. If you see it, it is like CH2OH, C double bond O. Okay, and then rest of the molecule. So due to this group, it will give the the Felling's test. CH3CHO contains a CHO group, so it will give the Felling's test, and this also contains CHO group, and it's an aliphatic aldehyde. You see, in option A is an aromatic aldehyde. Aromatic aldehyde will not give Felling's test, but this is an aliphatic aldehyde. CHO is connected to aliphatic carbon. Okay, so it will give the Felling's test. So C, D, and E will give the Felling's test. So the correct option should be option 3. Next is, okay, question number 66. The IUPAC name of following compound. Question number 66 is asking for the IUPAC name of the following compound. In this compound, there are two functional groups and both are chain terminating groups. Now, carboxylic acids will have higher priority over esters. And this ester is a C-terminal ester, which is looking something like this. Now for this, the prefix will be methoxy carbonyl. The numbering will be starting from the senior functional group. And 1, 2, 3, 4, 5, 6. Remember that whenever you have got a chain terminating group as a substituent in a molecule, its carbon will not be the part of parent chain. Okay, so if we are writing the name of this molecule, okay, the word root and the senior functional group will be hexanoic acid, and you have got methyl group at second position. Okay, and methoxy carbonyl. So methoxy carbonyl will have alphabetical priority. So it should be 5 methoxy carbonyl. Carbonyl. And then 2 methyl hexanoic acid. Now, none of the given options will be correct because, but the closest option will be option 3. Okay, so this question has actually been challenged by a lot of students because of this rule. Okay, but those who have to select an option have taken option 3 because they have included the carbon of ester in the parent chain, which is not correct, but as per the given option, this is the best possible option. But 66 should go for a challenge. Okay, next is question number 67. How many different stereoisomers are possible for the given molecule? Now, this molecule contains a chiral center and a double bond. Okay. Now, this double bond can have E, comma Z, and this chiral center can have R comma S. So we have got 2 into 2, 4 combinations. One will be RE, then RZ, then SE, and SZ. So total 4 stereoisomers will be possible. Correct option will be option 2. Question number 68. A vessel at 1000 Kelvin contains CO2 with pressure of 0.5 atm. Some of CO2 is converted into CO on addition of graphite. If total pressure is 0.8 atm, then find the Kp value. So let us write the equilibrium equation. CO2 plus carbon is giving 2CO. Okay, we should write the states also. This is gaseous, this is solid, and this is gaseous. Initially, the pressure is 0.5 for CO2. This will not have any pressure, and this will have zero pressure initially. Equilibrium, let us say 0.5 minus P, and this will be 2P. So P total at equilibrium will be 0.5 minus P plus 2P. It will be zero point 0.5 plus P, and that will be equal to 0.8. So value of P will be equal to 0.3. So this value will be 0.2, and this value will be 0.6. Okay, so Kp will be equal to pressure of CO square by pressure of CO2, 0.6 square by zero point 0.2. So this will be equal to 1.8 atm. Okay, so the correct option will be option 2. So 69 is a match the following question. So list 1 and list is given as some sequence, and list 2 is having the properties. Now Al3 plus Mg2 plus Na plus and F minus in an increasing order. Now all these are isoelectronic species with 10 electrons. Okay, so in case of Al, more is the positive charge, smaller will be the ionic radius. So A should be corresponding to 4. And after this, if you're looking at option B, boron, carbon, oxygen, and nitrogen. Now, from left to right, generally the ionization enthalpy will be increasing. But in case of group 15 elements, will have slightly higher ionization energy than group 16 because of stable half-filled configuration. So BCON, this will correspond to ionization enthalpy. Option C, boron, aluminium, magnesium, and potassium. Okay, so this will be metallic character, because metallic character will be highest for the group 1 elements, and as you go from left to right, the metallic character will be decreasing. So C should be corresponding to 2. And D, silicon, phosphorus, sulfur, and chlorine. Okay, so this will be the last option, which will be option 3. Left to right, electronegativity values will be increasing. So A4B1, C2, and D3. This will be option 3. Okay. Question number 70. Lanthanide configure ions with a 4F7 configuration. So first we write the configuration EU2 plus. Configuration will be xenon and 4F7. For gadolinium 3 plus, the configuration will be xenon and 4F7. For EU3 plus, now obviously if EU2 plus is 4F7, EU3 plus will be 4F6. For TB3 plus, the configuration is xenon 4F8. And for SM2 plus, The configuration is xenon and 4f6. So only EU2 plus and GD3 plus will be having 4f7 half-filled configurations. So the correct answer should be option A and B. So it is option 2. Okay, so this concludes our single correct questions part. Next we will be moving to the numerical part. Okay, so next is question number 71. In Carrier's method for estimation of halogens, 180 mg of organic compound produces 143.5 mg of AgCl. Find the percentage chlorine in the given compound. Okay, now what will be the moles of chlorine should be equal to moles of AgCl. Okay, the moles of chlorine will be weight of chlorine, which is okay by 35.5, and moles of AgCl will be weight of AgCl by molar mass of AgCl, which is 143.5. Now, if weight of Cl is in milligrams, the weight of Cl can be written as 35.5 by 143.5 into weight of AgCl, and percentage chlorine will be equal to weight of chlorine by weight of compound into 100. So that will be equal to weight of chlorine will be 35.5 by 143.5 into weight of AgCl is given to be 143.5 mg by weight of compound is given to be 180 mg. So mg units will cancel out into 100. Now this will cancel out, and this will be like 355 by 18. This will be close to 20. Okay, since it's a numerical value integer, okay, then actual answer will be something like 19.72. You can approximate it to be 20. So 71 answer should be 20%. Okay, next is question number 72. We have a reaction which is A giving B, for which some K value will be there. And we can write this K as A e to the power minus Ea by RT, which is my Arrhenius equation. Now it is given that the temperature is 1000 Kelvin, activation energy is 191.48 kilojoule per mole, and the frequency factor is 10 to the power 20. Now the time required for 50% molecules to become to be converted from A to B, there is the T half. So we can write this as ln of K is equal to ln of A minus Ea by RT. Now ln of K will be 2.3 log of K. Okay, and that will be equal to 2.3 log of A, and A value is 10 to the power 20 minus Ea, which is 191.48 into 10 to the power 3. This is very important. By R is 8.314 into 10 to the power 20, 10 to the power 3. So this will cancel out because temperature is 1000 Kelvin, and you will be getting 2.3 log of K is equal to 2.3 into 20 minus this value will come close to 2.3. So just sorry into 10. Okay, so this will come out to be 23. So if you cancel out, this will come out to be log of K equal to 10, or K value will be equal to 10 power 10. So T half will be ln of 2 by k, that will be equal to 0.693 by 10 to the power 10 seconds, that will be equal to 69.3 into 10 to the power minus 12 seconds. So it should be 69.3 picoseconds. Okay, so the answer should be 69 in this case. Okay, this is question number 72. Next is question number 73. Okay, now this is an organic chemistry question. So consider the following reaction sequence. So I am just writing the reactant. Now NO2 on treatment with SnHCl, this will give NH2, and this with NaNO2 plus HCl, which is essentially HNO2, you will get diazonium cation and 2 plus. And this with Cu2Cl2. Now Cu plus halide is there, and then it is the Sandmeyer reaction. So N2 will be replaced by Cl. And then with sodium and dry ether, it will be the Fittig reaction. So you'll get a biphenyl. So its molar mass will be 154. So the answer should be 154. So question number 74. Some CO2 gas was kept in a sealed container at a pressure of 1 atm and 273 Kelvin. This represents the STP conditions. Now, some entire CO2 was passed through calcium hydroxide solution, and excess of unreacted calcium hydroxide was neutralized by 0.1 molar 40 ml HCl. So, what is the volume of container which contains CO2? It is given that entire CO2 reacted with only half of the initial amount of calcium hydroxide. So, let us say that the moles of CO2 is x millimoles. Then that will also be equal to moles of H2CO3. Okay, because CO2 plus H2O will be giving H2CO3. Okay. Now, this H2CO3 is passed through a titration process, and calcium hydroxide will be a source of OH minus. Okay, and the extra OH minus which is left will be neutralized by HCl. Okay, so milliequivalents of HCl, which is used in the step 2, will be equal to 40 into 0.1, that is 4 MEQs. So milliequivalents of this will also be 4 MEQs. And from the last line, that in the first step only half of OH minus is used. This means that half of OH minus remained for the second step. So OH minus in the first step in which we have taken is initial amount should be equal to 4 MEQs into 2. Okay, so this will be equal to 8 MEQs. So milliequivalents of OH minus used in the first step will be 8 minus 4, because 4 MEQs are used in the second step. And this will be equal to milliequivalents of H2CO3. So H2CO3 milliequivalents will be 4. So an N factor of H2CO3 is 2. So millimoles of H2CO3 will also be 2. So if H2CO3 is 2 millimoles, then NCO2 is also 2 millimoles. Okay. Now you see that if moles of CO2 is 2 millimoles, then volume of CO2 will be 2 into 10 to the minus 3 moles into molar volume. which is 22,000.4 into 10 power 3 ml. So this will be 44.8 ml. And if we approximate it to the nearest integer, it will be 45. So this is question number 74. Okay. Now next is question number 75. The number of molecules slash ions that show linear geometry among the following is. Okay, so they are just asking for which of them are linear molecules. So SO2 is a bent molecule. Okay, BeCl2 is linear. It is having sp hybridization. CO2 is again linear because central atom is having sp hybridization. N3 minus will be something like this. N double bond N, double bond N. This will be plus, this will be minus, and this will be minus. So this is again linear. NO2 will be bent. Okay, and this will be plus charge. Okay, so NO2 is not linear. Then you have got OF2. OF2 is again bent with central atom having sp3 hybridization. XeF2 is having sp3d hybridization, but it will have three lone pairs in equatorial plane. So it is linear. So XeF2 will come. NO2 plus will have a linear shape because of structure like this. I3 minus is just like XeF2. Okay, having three lone pairs in equatorial position, and the center hybridization is sp3d. Okay, so this is linear. Ozone is a bent molecule again because of this type of shape. The central atom is sp2 hybridized. So total 6 should be the answer. So this concludes our discussion on 22 January shift 1 paper of chemistry. Thank you everyone. I hope you uh, got benefited from this paper discussion. Okay.